In pharmacology, the usual pattern of discussing every chapter of drugs is like discussing a sickness first or a disease, a condition, and then talking about the drugs and then how they work. However, for the ANS, it's quite unique because here the central point is less on the drugs but more on the system, which includes the cholinergic and adrenergic divisions. So this is perhaps the only time that we will first cover the fundamentals of the neurotransmitter and the receptors before going to the drugs. I believe that if you don't do this, you will absolutely get lost when it goes to the actual cholinergic and adrenergic medications. Without further ado, let's start. I will first mention about the life cycle of the neurotransmitter here, which of course is acetylcholine, and then again, as promised, talk about the receptor types. So here we have a standard, picture of what you see in your physiology books. The transfer of signals from the brain all the way to the effector organ. So we have the presynapse, which usually contains the end of the neuron. The synaptic cleft, which is the space between the neuron and the ultimate effector organ. And of course, the effector organ, which has the receptors that once you activate will give us the effects that we studied so far before. Okay, so we start here and assume that there's a molecule of choline. CH stands for choline. Here, we will not ever be talking about why is it there, where did it come from. That's biochemistry already. And then we assume also that we have an acetyl group coming from acetyl-CoA. They combine by an enzyme that I think I will not name anymore, and we will produce acetylcholine. Okay, and then this is the synthesis part. After the synthesis of acetylcholine, it will be stored in vesicles because it's a well-known fact that a good amount of neurotransmitters are only released by vesicular fashion. Okay, so this is synthesis, this is storage. And then, of course, in order to be effective, it must be released. All right, without being released into the synaptic cleft, then how will it go to the receptors? How will it bind? How will it elicit any effect? It's impossible, right? And for this to happen, usually the trigger for our cholinergic neurons is the entry of calcium ions. So when this goes in, this goes out, it can now freely roam the bloodstream in the synaptic cleft, eventually reaching our two types of receptors for the cholinergic division, either the muscarinic, that's the meaning of M, and nicotinic, that's the meaning of N. Those are named after the compounds that help us discover these receptors many years ago. And of course, we finally get the effect that we have here for the parasympathetic side. So of course, once binding is done, we have to remember that binding is not permanent here, and acetylcholine will dissociate from this or this. Once that happens, it can be terminated or will probably be killed in a way by the enzyme ACHE or acetylcholinesterase, giving us acetate and choline. Of course, once this happens, then there's no more of these things. So just as a trivia, it's nice to know that the meaning of ACHE is acetylcholinesterase because the truth is acetylcholine is an ester, RCOOR. So that's just a little trivia for our chemistry savvy watchers. And once this happens, hydrolysis will happen, breaking this down into, again, acetate or in the an ionized form acetic acid and choline. That's it. So that's the life cycle of acetylcholine from synthesis to termination. Now, of course, equally important to knowing the life cycle of acetylcholine is the subdivisions of our receptors, because knowing this will help us know how our drugs later will work. First, we will talk about the muscarinic receptors here. I listed 3. The truth is there are 5 well-known muscarinic receptors. Currently, there are probably more than that, but I even cut it down to 3 because these are the only ones that we need to know to understand our basic drugs. The M1 receptor will cause wakefulness, memory, and HCl production once activated. Actually, in wakefulness and memory, I really didn't mention it here because the brain, which is really not a part of the ANS in the first place, is not included. But I thought it's important for reasons I will mention with some drugs later on. HCl production, luckily, is found here. So there's that. For M2 activation, we have decrease in heart rate, which is here. Sometimes the word for heart rate or a technical term for heart rate is chronotropy, because rate is like something related to speed, right? Time, and chronos is the prefix meaning time. If it's going down, then we say negative chronotropy. If it was going up, that's positive, but here it's negative. For M3, it actually takes a lion's share of the parasympathetic effects, as you can see. Increased GI motility, increased secretions, and by secretions, we are referring to sweat, saliva, and tears. Bladder contraction is here, which actually leads to urination. Meiosis, of course, we already know that very well. The narrowing of the pupil and bronchoconstriction, which is also there. All right. There is not so much mention of effect on blood vessels in the uterus. So maybe if there is innervation, so far our drugs related to the cholinergic division don't really touch on these. So they're not mentioned as much. Now, for the nicotinic receptors, we have two subtypes, NN and NM. N stands for neural, so when you stimulate it, it causes neural excitation, which is quite a general description of an effect, right? But that's a good thing because at least we will not be mentioning this in the ANS. Another thing is NM. M here, you could assume stands for muscle. So NM will cause skeletal muscle contraction upon its activation. Now, this is also quite weird because, when you contract skeletal muscles, that's something that you can control. Your fingers, your arms, your legs, your facial muscles, your neck, everything else. So technically, that's not autonomic, right? Because autonomic means those are things that happen without your control. This is why I noticed that in textbooks, this one is something that not everyone would agree upon. There is this camp of references wherein drugs that act on this receptor are still included in the ANS because, after all, NM, nicotinic receptors, are still part of the cholinergic division. There are other references which exclude this from the ANS because the effect that we are looking for is not really an autonomic one. But whenever you encounter, opposing references, do note that there's an explanation behind that. But the good thing is, for most part, it's a universal agreement that these three are definitely purely, not really purely, but a lot of it is autonomic. So we will focus on this when we go to the agonists and antagonists.